Good evening, everyone, and welcome to our Boreal Nature series for today. We are joined with Dr. Mark VER, and my name is Riel Massey, and we are from the NAIT Center for Boreal Research. Before we continue with the presentation, I just have a couple of housekeeping items for us. The first one is that there is a Q&A feature on the right-hand side of your screen, and you can use that to pose questions during the presentation tonight. We will be answering those at the end of the presentation, so please include as much information and context as you need for the question, and perhaps reference a slide if it's applicable. Next, we will be recording the presentation for the evening, and that will be posted later on the Center for Boreal Research website. If you miss any of the slides today for technical difficulties or other reasons, you will be able to catch up at a later date. And finally, I want to thank our sponsors for the Boreal Nature series and partners in Boreal education, and they are NSERC, FRIA, Canadian Forest Products, Mercer Peace River Pulp, West Fraser Manning Timber Co., Boucher Bros, and Zavisha Sawmills. So without further ado, Mark, you can begin when you're ready. I think you're just muted, Mark.
Okay, am I good?
Yep, perfect.
All right. So my name is Mark VER. I'm a research associate with the Center for Boreal Research here in Peace River. I am part of the upland reclamation team, and I've been working with NAIT since September 2018. So basically, most of our work is about land reclamation and forest management. And today I'm your presenter, and this is my presentation is about a work that an ongoing applied research that we are doing with Capital Power at the Genesee mine in west of Edmonton. And basically, the title of my presentation is Vegetation Management Practices for Accelerating Dominance of Native Plant Species on Industry Reclaimed Sites. Okay, so before I go to the actual trials, I just want to give an overview of this whole work. And in general, vegetation establishment, especially when it comes to land reclamation, one key challenge is in terms of revegetation the area after land mined or after mining is a high mortality and then slow growth rate of planted species. And this actually comes from severe competition with weeds and other undesirable vegetation. And when it comes to the management and controlling of these weeds on the reclaimed sites, this is very important. One, weed management, and two, trying to bring back soil nutrition are some of the key challenges that we usually face when we are doing revegetation on reconstructed landscape. And also, most of the species that we encounter on site, most of the weeds fall within the realm of perennial species. And because these species have very high fast growth rate and reproductive cycles, it is very difficult sometimes to deal with them. So overall, we for the past years that I've been with NAIT Center for Boreal Research, most of our trials has been has been dealing with some of these weed issues on our reclaimed sites. So with this particular trial that is ongoing at the Genesee mines, we are actually trying to combine what we call 3 principles, because before the area that is reconstructed, before the area and the revegetation can be certified, then one key thing is to be able to recreate or able to develop native species cover. And in so doing, we are using 3 principles in terms of bringing back native species onto the area. And the first principle is to overwhelm the reclamation site with desirable plant community by enhancing native species cover. And the second one is to use native forests to exclude undesirable competitor species at the microsite scale. And the third one is to actually give the native species a head start in terms of growth by excluding competition. So when we talk about overwhelming the reclamation site with desirable plant community, you know, this principle includes species that will contribute to increasing the understory plant diversity, as well as early site occupancy. And also, so in general, what we usually use is native forests. And these native forests, in terms of, they come in form of fireweed, showy aster, and then golden rod. And our second principle that we use to our second principle also with this approach, it deals with the establishment of native species that is focused on growing planted nursery stock seedlings rather than planting individual trees. So we actually combine trees with tree seedlings with native forests and plant them together. So this is the photo that I'm showing is a typical example of how we combine goldenrod with tree seedlings. But you could see that some of the seedlings like spruce, when you go to the site and you open where the goldenrod is, you could see that the goldenrod has given some form of protection to the spruce that actually allows it to be susceptible to competition on site. And the third approach is when we tend to give the native species a head start. And this usually comes in the form of applying weed suppression treatments. And a typical example is applying a recommended weedicide before you plant your seedlings. So for this work, it is basically about these 3 principles. So in terms of the objectives of this study is to test these principles by excluding undesirable pioneer species on reclamation sites at 2 different implementation skills. And the implementation skills involve 1, using a weed suppression treatment, and then using a native plant occupancy treatment. And as I go through my presentation, we will get to know the different treatments that we use to test these principles. So for the weed suppression treatments that we applied on site, the first one, actually every experiment will come with a control where we don't apply any treatment. And the second treatment is a strip application of wood mulch. And the third treatment is the The third is a strip application of film mulch, and then the fourth is applying a pre-emergent herbicide. And in this case, we use a herbicide called Torpedo, and the third is rototilling the site. So this weed suppression treatment, we applied it in order to suppress the initial growth of the weeds and give the seedlings that we put in the ground, the tree seedlings, a head start to develop. Now, when it comes to the wood mulch, so the photo here demonstrates how the wood mulch was applied onto the site. And usually it's a 2-inch layer of wood chips that suppresses most weeds. And those that do damage, it's a 2-inch layer of wood chips that we apply in order to suppress most weeds. And when it comes to the wood chips, it do breaks down over time. So one advantage is it does break down over time, and allowing the weeds, like the wood chips does break down over time. So overall, it helps to suppress the weeds and allow seedlings to grow over time. And the film mulch that was used on site is what we use for this particular project is a biodegradable plastic mulch. And these mulches are environmentally sustainable compared to when you are using conventional polythene mulch. And the biodegradable plastic mulch, as being shown in the photo on the screen, we tilled into the soil, and we expect them to biodegrade over time. And one benefit of this mulch is also how it affects the microsite, because as a surface barrier prior to soil incorporation, it directly impedes weed emergence, and also it also regulates the soil microclimate that also help to affect overall weed regeneration over time. And the fourth weed suppression treatment, as I mentioned, is a pre-emergent herbicide. And for us, we use Torpedo. And usually, like I mentioned earlier, when you are dealing with sites where severe competition pressure from agronomic or weedy species may be necessary, agronomic species, then it's necessary to use herbicides to create growing space for the target native species. So if you see the photo, you could see that the spaces that has been created in the photo on the screen is as a result of the herbicide application. And for this herbicide application, we first apply the herbicide, and then we plant our seedlings through the site. And the herbicide, the herbicide that we use, that is the Torpedo, it works as a thin film that when you apply across your site, it will block the emergence, because it works as a film, a thin film. It will block the emergence of weeds. But because we plant our seedlings through the site, the seedlings, it will allow the seedlings to grow. And we've tested this torpedo at other sites in near Fort Mac, and we've not found any residual effect on seedlings. So, and then the fourth one is the rototilling. So the photo shows here, because the site that we were dealing actually has a significant issue with pipe grasses. So our investigation suggested that when you rototill a site, it has been shown to have a significant effect on grasses, especially pipe grasses. So that's the more reason why we also use the rototilling as a weed suppression treatment in this field trial. So I mentioned earlier that we are testing the principles. We tested it in 2 different treatments. That is the weed suppression treatment, and then the second treatment application is the native plant occupancy treatment. And this is simply a method of incorporating native plants onto the site, different techniques. And like I mentioned, for this treatment group, first, where we didn't plant or establish any native plant. And the second one is using grass seeding. So because the slender wheat grass has also been found to be able to compete with weedy forbs. So we also use 10 kilogram per hectare of slender wheat grass as a treatment. And then there's a technique that we also call as a hitchhiking of native forbs. And that one I will explain it as we go along. And the last one is another technique where we've also given the name as a root in a bag. So these are different techniques of introducing native plant species onto the site. And the overall aim is to be able to overwhelm the reclamation site with native plant species, because while the first treatment, that the weed suppression treatment, is blocking weeds from flashing or overtaking the site, then there should be other ways of also increasing the number or the coverage of native forbs, and that is what this different treatment groups will also do for this trial. So the hitchhiking approach, or somebody will ask what is hitchhiking? And for the hitchhiking method, here we actually grow forbs, or the forb. If you see in the picture, we have like white spruce and something like goldenrod put together in the same cavity of stereo block. And the important is so that the seedling, the tree seedling, and the forb will germinate in the same cavity and transport it onto the site. And it's an effective way of introducing native forb cover onto your site. And this technique is it borrows from the broader concept of companion planting, which is a type of polyculture planting typically used by gardeners and nursery growers to aid in pest management, also fix nitrogen, and exclude pests. So, for instance, if you plant your tree seedling with a leguminous plant, then in this case, there could be a way of helping the leguminous plant to fix nitrogen and directly benefit their tree seedlings once we transport it onto the site. And the next technique of introducing native species or native plants or native forests onto the reclaimed site is what we call it as a roots in a bag technique. And if you see, this is the photo shows how the plots that we develop using the roots in a bag technique. The simple objective of this technique is to be able to generate or create as many root materials as possible that you can easily transport it onto your site and establish. So this planting approach takes advantage of the vegetative suckering potential of some tree species, of certain native plants, to establish them on the reclaimed site. And in doing this roots in a bag technique, we also apply it together with fibrous organic material, and such as hydroseeding. And when you do that, it has a potential to provide an improved seed germination environment, and also to increase the emergence rate of the root material. And this is the first time that we tried this planting technique onto our work, or we tried this planting technique as part of our trials. So the photo on your screen, on the screen, actually shows how the root materials, after growing it in the greenhouse and cutting the root materials into certain length, how they were incorporated onto the site. So like it shows how the root materials were actually applied or incorporated onto the site. So for this particular trial, I have a map where one area shows green mesh. So this is where we applied the different treatments. So you could see that on the screen we have on the legend we have the main plot treatment. So this trial actually used a split plot design to test the different treatment combinations. And you could see that the main plot treatment is torpedo, wood mulch, film mulch, rototilling, and then control. That is the weed suppression treatment. And within each main plot treatment, we also apply the native plant established or occupancy treatment. And that is we use the normal planting. That is the way how commercially trees are planted as a control. And then we also tested our hitchhiking planting technique, and then roots in a bag planting technique labeled as R, and then the grass seeding technique also labeled as G. So this is how the different treatment combination was applied onto the field. So overall, how did this method of testing the principle of accelerating native plant cover work in terms of and one key thing is this study was done is ongoing at Genesee Mines in the parkland region, and we all know that that area is more like agricultural land. So issue with weed is very severe, and that is why we try to test different ways of being able to overcome the weed issue in that area. So the slides that will follow will show us overall how the different treatment combination or the different treatment perform in terms of suppressing weed and in terms of overwhelming the site with our native plant species. So for this particular study, we planted white spruce, aspen, balsam poplar, green alder, and Canada buffaloberry and other tree and shrub combination. But for the sake of time, I'm presenting the results on white spruce and aspen, and if there's more time, I can show the other tree species. So in terms of our white spruce development in the different, so when I'm plotting white spruce, like the first column for the graph shows white spruce development from year 1, year 2, year 3, as affected by the different weed suppression treatment. And the second column of the graph also shows white spruce development from year 1 up to year 3 as affected by the different native plant occupancy treatment. And the way I've plotted the graph means that I didn't get any significant interaction between the main plot treatment, which is the weed suppression treatment, and then the native plant establishment treatment. So we could see that in general, overall observation is that the white spruce, the balsam poplar, and especially the aspen actually reappeared, because in the first year we recorded very low mortality for very low density for most of the trees and shrubs that we established. But as it goes to year 3, we started seeing most of the we started seeing more than half of the seedlings that we put in the ground. And for white spruce, like white spruce, you could see from the graph that white spruce establishment using the hitchhiker approach actually show the highest density success, while those planted with the normal approach or the control treatment by year 3 actually show the lowest density. So the hitchhiking approach was most beneficial to white spruce establishment, and it was very obvious in the field, because actually when you plant the white spruce, what my personal observation in the field while doing the survey study, when you plant the white spruce with native form like goldenrod, and the goldenrod becomes very successful. In fact, you could see that by year 3, the goldenrod is actually growing around the white spruce and shielding it from the rest of the noxious weeds. So once you see a group of goldenrod growing together and you open it, you will see a tree in the middle, and it's well protected and it's growing very well. So it was very good results that we found in terms of the hitchhiking forms with trees and then shrubs. And also in terms of aspen density, we found out that when you apply the film mulch, it actually helped the aspen to develop very, very well. And it's very obvious because aspen is very susceptible to competition. And in plus that, because the film mulch, we planted the trees, the seedlings through the field mulch, after year 3, you could see that the mulch has actually protected the area around the trees, the seedlings or the tree seedlings from weeds, and that actually helped the aspen in particular to develop very well, and we recorded very high density by year 3 as compared to even the first year. And the first year for most of the tree seedlings, recording was very low in terms of overall density, and was actually due to the fact that as you come across many large coverage of weedy species, most of the surveyors actually miscounting most of the seedlings that were still in the ground. And by year 3, because our treatment may have suppressed the weeds, you could easily see most of the seedlings growing. So, and the best results in terms of aspen was found in the field mulch. And given that young aspen can be highly susceptible to competition with herbaceous vegetation, the seedlings seem to be like the seedlings that by year 3, the aspen seedlings were actually seen to be responding to the film mulch treatment because of the reduced competition pressure from the non-native forms by year 3. So this is a pictorial presentation of the stem density across the whole site. So we recorded the density of all the tree seedlings, and we plotted and we map it from year 1 up to year 3, and you could see the differences in terms of density increment from year 1 up to year 3. Although we cannot conclusively, because these seedlings are still young, only 3 years, we cannot conclusively state that any of the native plant establishment treatment technique have led to woody vegetation overwhelming the site. It's important by year 3 to note that the total density of the target species actually increased consistently from year 1 through year 3 in nearly all the treatments, as it is shown from this map. And the spatial analysis that we did revealed most of the reclaimed sites now occupied by at least 2,000 stem per hectare of trees and shrubs. So if you look at the map for year 3, it has moved from green to blue and some small spots showing deep blue. And this area occupied more than 2,000 stems per hectare of tree seedlings, where even in year 1 is mostly less than between 0 stems per hectare to 1,000 to 1,500 stems per hectare. So this actually gives a clear indication that with the treatments over time, we've been able to have a success in terms of overall growth and survival of the tree seedlings that we establish. And one thing is while doing this work, we suspected that the total density of the target species, or the trees and the shrubs, increased substantially over the 3-year time period because of the consequences, or because of increased height. Because by year 3, you could easily see most of these seedlings coming out of the weeds, and that actually make the individual plants very easy to detect and also record during our survey exercise. So this is a pictorial presentation of white spruce from year 1 up to year 3. So we planted white spruce at 700 stems per hectare throughout the whole site. And by year 3, we could see that there are more areas with 600 stems per hectare or more spreading across the site, compared to the first year, where most of the site we recorded very low density of white spruce. So the white spruce planted at 700 stems per hectare, by year 3, we confidently know that we've not lost much in terms of the initial density that we put on the ground. And the next one is aspen. So similar story. So aspen, we actually like from year 1, when you look at the middle section of the plot, you could see that is where most of the aspen were doing very well. And when you move to year 3, aspen development starts to get better across some section, more sections of the site. And then year 3 gives the a situation where aspen really is doing really well in the middle section of the plot and other areas. But overall, compared to the first year and then the 3rd year, aspen in general is also doing very good. One particular species that was really hammered by the weeds is actually green alder. So for some reason, green alder was doing well in the initial stage, because by year 1, we have right after establishment in June, we went back to record in August. So weed coverage was really low. Green alder was doing well across the whole site. But when you look at the 3rd year, you could see that we lost almost all the green alder. And this results actually contradicts with what some of the results we've gotten earlier from different sites. Green alder happens to be one of the shrub species that actually compete very well with herbaceous species. And we actually suspect that it could be that the site wasn't, the soil condition wasn't good for green alder establishment. That is one thing that came to mind. Probably the green alder wasn't good for that particular site. That's why it has reduced significantly by year 3. So for this particular study, it's about suppressing weed, noxious weeds, and allowing our seedlings to do well or survive more. So by looking at the tree density, we are also looking at the coverage of the forbs over the 3 years. And the forbs, we break it down to native forbs that we are more interested than the non-native forbs. So if you look at the photo on the graph on your screen, the first row is about native forb development by year 3. The second row is a non-native forb development by year 3. And the third row is total forb development by year 3. And what can we say about the overall native forb development? Because the native forb, we as part of this study, we intentionally planted goldenrod, aster, fireweed in the hitchhiker treatment. So overall, you could see that we found out that though the graph is in here, the native forbs coverage increased over time in all the experimental treatments. It's actually based on the, if I quite remember, on the first year, we recorded an average of 4.5% of native forb cover. And by year 3, we've actually gotten about more than 13% of native forb cover. And we found out that if you look at the native forb cover under the native species establishment treatment or occupancy treatment, I think the highest from here is under the hitchhiker, and then the next is the roots in the bag treatment, and followed by the grass treatment, and then the normal planting treatment. And the native forb cover under the hitchhiker and then the root in the bag is more by year 3, because the hitchhiker, for instance, we actually planted native forb together with the tree seedlings in the same cavity and transplanted it onto the site. So the addition of goldenrod, fireweed, and aster actually showed a marked change with like most of the forbs, the native forbs coverage in the hitchhiker came from the goldenrod that I mentioned earlier. That across the site, we found out that goldenrod was really doing well, shielding the tree seedlings from the bad weeds, from the weeds. And also one thing that I want to bring about, that initially we had some concern that using the pre-emergent herbicide, that is torpedo, could compromise or negatively impact the early growth or survival of the native plant species. And from what we have in terms of the native forb under the 4 weed suppression treatments and the control, we realized that the torpedo in particular didn't inhibit or negatively affect the native herbs development. It's actually, like, if you look at the graph in the first graph in the first column, you could see that the native forb development under the torpedo was even the highest compared to the other treatments. And when you come to the non-native form, that is the second row. The second row. During the first 2 years during the first and second year of this trial, the non-native form cover, we encountered a lot of non-native forms across the site, and that actually constituted a potential impediment to the survival and growth of the target species. That's the more reason why when I show the maps of the different tree species and then the total stem densities, you could see that by year 3 the density was very low across all treatment, across all tree species, because the non-native form cover, especially Chenopodium, was really thick and very difficult to walk through and even to see, record the surviving tree species. And but when you look at the by year 3, so the graph is actually showing only the year 3 results. So the torpedo treatment significantly, that is the torpedo, that is the blue bar, significantly reduce. The torpedo treatment in general was more effective, in reducing the non-native form cover than the other weed suppression treatment. And this is basically due to the residual nature of the torpedo, where I explained it that when we prep the site, we apply the torpedo that function as a film mulch. So once the film is not broken, it prevents weed germination from seeds. In most cases, it prevents weed germination from seeds. And once you plant your seedling, it has no negative impact, and it will allow the seedlings to get a head start in terms of growth before, over time, the weeds come in. So that's the more reason why we recorded low coverage of non-native forms within the torpedo treatment. And okay, so this is what I was explaining earlier about the hitchhiking treatment. So it actually worked. And if you see if you look at the last photo on your right, you could see the golden rod appearing among the grasses. But within the center of each golden rod, when you go there, you see that the area is cleared of weeds, and tree seedlings are growing under the golden rod. And there was benefit because, one, we actually encountered some browsing on the site. And once the seedlings are covered by the golden rod, it also prevented these seedlings from being browsed and destroyed. And that's the more reason why we believe that the hitchhiking treatment is actually good for some sites like this, where weed is a very big issue. Once the golden rods do very well, then they can actually serve as a protective shield when hitchhike with tree seedlings. So my next slide is all about photos, and to give you a pictorial presentation of how the different treatments did. And I'm just going through quick, and then we will complete I will complete this presentation. So the photo that you see here is our control treatment. So the control in terms of the weed suppression, and then the control in terms of our native plant occupancy. So you could see that where we didn't apply any weed suppression treatments and where we didn't include any native plant establishment technique, most of the site was completely overtaken by weeds. And the photo here, you could see one or two aspens growing, but overall, it was completely dominated by weeds. And this is also shows that we didn't apply any weed suppression treatment, but we also incorporated grass seeding technique. And in most cases, you could see because the grass actually competed with some of the frogs, but this track did not really help to suppress the non-native frogs. And it recorded very low, but it did very well than the two control combination. And you could see more aspen and other tree species appearing in the treatments. And this is no weed suppression treatment, that is the control, but we actually hitchhike the tree seedlings with native frogs. And here we can't see the most of because the golden rods that are showing in this photo are doing very well, but within where in the midst of the golden rod, most of the cases when you go and you open it, you could see that our tree seedlings are really doing well and they are being shielded from the weeds. And there's also instances where you could see aspen and other tree species appearing in the background.